As promised last week, I have pre-created some decoders and rules to go through to create or to show the examples of the different mechanisms and ways of which you can create the decoders. So we're going to run through a quick recap of the discussions we had in the previous session, and then we'll move on to the rules and the considerations for those. I am the presenter, Louis, for those that haven't been here before. And we've got, as panelists, we've got Mandana from sales, and from technical side, we've got Chris and Jim. Chris is the CISO, and Jim is our lead solutions designer. So if you have questions, feel free to type them in the chat box, and we'll address them as we go on. I've included the considerations again. These are just generally good sources to read through when you're creating your own decoders and rules, etc. It is advisable to bookmark them because you will reference them even once you've become used to creating these things constantly. You will still reference these sources for examples and maybe just a refresher on specific values and options, etc. So we covered the data structures differences between archive log and archive JSON in the previous session. These have been updated to reflect the changes that I have made to the decoder. You will notice that the top line in the archive log just gives the raw data that is received by the Wazuh environment, and the data structures for the archive JSON includes the description for my decoder that was used, as well as the decoder name that was used. This is pertinent when you're validating if your decoder is functioning correctly to ensure that that decoder that you've created is the one catching the data, or if it's simply being caught by the syslog listener, etc., without being decoded. So it is very important to take note of that when you're testing your decoder and testing the output in the archive log. This is raw JSON format, so you can literally copy it from the first bracket there, or the brace, to the last one, and you can paste that into a code editor, and you can switch the formatting to JSON, or you can run it through a command line tool like JQ, and that will give you a neat layout of what the data structure looks like. So when it comes to decoders, there's the old method, which is multiple extractions in one code block. Then there's the new method, which is a singular attribute extraction. There are some considerations between the two of them. Neither one is wrong, neither one is right. It all depends on your type of coding style, as well as how the complexity of the data that you're working with, and how much time you would like to spend on that. So the old method is very volatile and sensitive with its extraction mechanisms, but it is significantly more concise. That I'll explain what I mean with concise after we've covered the singular extraction. Singular extraction is safer. You can more easily adapt it so that if you have multiple firmware versions, and your general structure is exactly the same, but the delimiters change, or the wording changes slightly, or the spacing changes slightly, you can adjust it so that you can see various items more to extract. So you can extract the source IP address, could be src IP equals inverted quotes and then the value, or the older version could be without the inverted quotes. So you'll need to create a match for both, and that's where singular extraction comes in very handy, especially if you're talking about firewalls and switches, because they tend to generally update the syslog outputs when you change firmware versions. It's safer in the sense that if your regular expression doesn't match, it will simply not extract that attribute, but all the other attributes can still extract. So you won't have, it's not a zero-sum game. You can extract 20 in total and one could fail, or two could fail, etc., but you will still have a significant portion of your data, and that's why it's safer. More adaptable, obviously, like I've said, if there's firmware versions, you can extract this in one code block. You can extract all the source IPs regardless of how it's encapsulated or formatted, etc., and it makes it simpler to troubleshoot. The downfalls are that it's overly verbose. Each decoder block that you create or code block that you create runs through CPU in cycles. If you have a large number of decoder blocks, this will have a performance impact. It will be more noticeable with high data volumes, but there is an impact. So there is considerations from a performance point of view, and that's where my concise comment comes in with the multiple extraction from one code block. Because with the multiple extraction, it runs through once and it extracts the data. With singular extraction, it runs through the whole string of data through each decoder block until it completes all of them in sequence. With large volumes of attributes, it is also quite possible to miss a specific attribute. So I've seen logs with almost 300 attributes to be extracted. And they may not be a key value pair system, so they don't give you an identifier in front of the value. And if you're sitting with multiple strings of digits, for example, inside one single event, you could very easily lose track of which piece of the puzzle you're working with. And I'll give you working examples as we go through tonight's webinar. So this is what a multiple extraction will look like. At the bottom, I've listed the data that was captured by the archive.log. And you can see that the pre-match is a string of characters. These are individuals. So for each W, it is one character. It includes most characters except spaces. So you can see that it is catching these items here before the comma, the 615C4D996B57. So that is the pre-match. So it will look at raw data coming in, and if it matches that, then it will declare that as a match. Your regex offset basically tell it, so after the pre-match, so after that string there with the comma, you'll see there's the string and there's the comma, start matching everything else. And you can see here that there's brackets with regex in the middle. So what that does is essentially, this one specifically will say this is the start of the text that it needs to be analyzed. And it will take everything that comes directly after that, but before the space that's listed here. And it will capture that as the first item that is being extracted. The braces or the brackets indicate each one of these items here at the bottom that's comma separated. So basically you run through this whole string of data and you put in regex for the values that you want to extract, and you put the brackets within the formatting of the data that you've received. So you can see there's square brackets here after kernel. There it is. So there's the square brackets and the kernel version in the middle. And you can see I said this will be a digit one or more times with a full stop, and then a digit one or more times. And I extract that value out of there and I link it to kernel. So you can see the kernel version. And the kernel version is the second set of brackets. So you can go 1, 2. So there's your second part. And you keep doing that for all the values that you want to extract. Once you've gotten to the end and you test and it doesn't work, that is why the multiple extraction is sensitive and volatile. You will have to then start trimming it back up to a point where it's working again, to make sure that your regex is accurate and pertinent to the data that you're processing. The chances of you making a mistake in this is significantly higher than on singular extraction. The benefit is that if you're dealing with high volumes of data flows and just in general, just large volumes of data, this will be more resource efficient in the long run. Because when Wazuh starts up, it loads all the decoders and the rules into memory. The more rules, the more decoders, the more memory it needs, the more CPU cycles it will consume working through all of them, because it works on a hierarchical structure. From a multiple or a single extraction point of view, you can see here I've put in a block that shows the basic regex that's supported by Wazuh. There are more advanced features available, but those are trial and error, not officially supported. This covers a great deal of what's out there. I have yet to encounter a situation where these will not cover your needs. So you can see here that I've created multiple code blocks that extracts one item at a time. So there's my pre-match, like I showed you in the previous one, and that one will always be true. And once it pre-matches that, it will step through all of these and see if that piece of information that I'm looking for is inside here. If it's not here, it'll move on to the next one. If it finds it and it matches it, it will publish it as an attribute with the order name that's been assigned there. Hope that makes sense. The catch of this is, of course, that even with a simple string like this, which would be the equivalent of a switch, you could end up with a decoder that is hundreds of lines long. And keeping track of which attributes, etc., is important could also contribute to missing a specific component. You will notice here that on this layer here, there is a word in the middle that isn't split with its value with an equal sign. So this makes it a little bit more interesting to extract. To give an example, you can see for everything else, it's quantified by the key value pair. So the key is what the data is, and the equal sign then denotes what the value is. But here there is no such delineation. The important thing to remember here is that this could be structured in any given way, and you wouldn't necessarily know what the original creators of the syslog or the guys that created the code would have intended for. So what you need to do in a case like this is create a decoder that encapsulates both this field and that field. So you would copy the res one. I'll pull up a code example in a second. You'll pull up the res one, and then you put the regex in there for the unkey value paired value that you're looking for, and then you'll include the follower as well. And that way you can define which option it is that is important to you there. So let me just quickly log into my session on the side, and I'll quickly show you what that code looks like. I'm going to switch the screen shares to the other one. Don't worry if you can't follow what's on the screen exactly. I will be sharing the decoder and the rule set that I've created, so that if you want to re-watch the video, you can work through that. You can see here that it's quite a bit more or quite a bit longer than this, the multi-extraction. And let's just go to the end, and you will see what I mean with what I explained there in a second. So you can see that it's extracting the res, and then it's saying that there's a space, and then anything between these two spaces, it will extract and put into the TCP flags, because that is what that field was for, and it will extract it into that. So it will not just match this value or hope that it matches the value. It actually defines it as a value that sits between two spaces, preceded by this text and preceded by that text. As you can see, preceded by this text and followed by that text. And that is the data that gets extracted in the middle. So when starting with the rules, after you've finished your data extraction and your attributes are mapping correctly and you've tested it with a lot of different data field lengths, because each type of appliance have multiple different types of source syslog outputs that they put into one syslog. So you could have one on a firewall, you could have one for UTM that's got web filters, TLS inspection, SSL inspection, port forwarding, etc. So you could have multiples. You need to test all of those. You need to have at least one or more lines from each of those types of outputs and test them to make sure that your decoders work. The testing is as important as writing the decoders. Once you've verified that your decoder is functional and working the way you want it, you need to start then creating your rule. So there's a couple of rules for the rules that you need to bear in mind in Wazuh. The rules need to be inside a rule group that you can give a name. In this case, I gave it the group name of webinar. Then you can see the rule number range. All rules inside Wazuh is numbered. It will not allow you to start a rule with a conflicting number. So it is important that you stick to your ranges, etc. They have published ranges on the Wazuh website. That is their standard that they would like to go through, as well as you can grep through your rules for an existing rule number to make sure that your rules don't conflict with existing ones. So Catchall rules is your primary that you need to start with. A Catchall rule is important because what that will do is it will get all the data that your decoders are breaking down for that specific syslog that you're ingesting, and it will allow you to analyze how it's being presented to Elasticsearch and how it's being stored. You can see your attributes from there. You can see the values and how it's displayed, etc. And it will allow you to come up with new and ingenious ways of creating additional rules that will cover needs for specific use cases inside your environment. Firewalls typically lend themselves to much more creative rules. Switches, etc. In a lot of cases, you've just got a catch-all rule. Or if you're just interested in a specific subsection of the decoded data, you'll have a secondary rule that will filter out everything else and discard those. And the reason for those, or for the switches to be under a catch-all, is in some cases compliance requires that you keep all your log flows and your traffic flows from your core switches or your network switches, etc., or from secure environments. Something to bear in mind with the catch-all rules is a lot of switches will generate a lot of events for even just a small action like a ping. You could end up sitting with 5 to 6 or even up to 10 lines just for a ping that come through from a switch. You have to ask yourself, do you want to keep this? This will exponentially increase your storage requirements. It will exponentially impact your memory and CPU utilization. So unless it's absolutely necessary for you to keep those, it is not recommended to do so. Just something to bear in mind. They provide no real value unless you're looking at tracking traffic down to that level. But if you're doing threat hunting at that level, you would also be required to have packet captures of the network so that you can replay attacks, etc. So it would be more feasible to maybe capture net flow in a situation like that into plain text files that goes into slow storage that you can analyze from at a later period. Okay, so the rule groups, it's to group everything into a collection. It's part of the structural syntax requirement for Wazuh rules. They've got best practices specified and they've got standards specified for both the formatting as well as the numbers going forward in the solution. So your rule ID is basically your alert ID, or the number of the alert that you're going to generate. It carries no value other than an identifier that you can find when you have to track which rule created an alert. There's a level, which indicates what the severity is or what the function was of the rule that was detected. And these are from 0 to 15. At some point, there was a level 16, but that's rarely in use anymore. Anything below 3 will be discarded. Anything 3 and above will be stored for later use. So the first step that you have to do when creating the rule is you need to have target data identification, like what I showed you in the archives.json file, where it showed the decoder that caught the data and split the attributes. You need that information to start creating your rules, and you need a description for it. Something to bear in mind is before you start creating the rules, you need to have a needs list. You need to create a list of items that you need from the log data that you're processing. If you do not have that, basically after you finished with the catch-all rule, your work will be done, but it will also only provide limited value to you, unless you have a compliance requirement where it's an absolute, and then a catch-all rule is fine. But it's important to start with what you're trying to get out of it, because once you have that, then you can identify the fields and the attributes that you want to work with to get you to that point. And that is why it's important. These are just some of the labels that you can add to your rule. The level 0 to 16, as I stated earlier, your rule ID, the maximum size of the event. If you do not have that specified, it will cut it off after 9,999 characters. The frequency of the rule, it's how many times it needs to match before firing, etc., the time frame, and so on and so on and so on. You can read through these at your leisure. I will show you some examples of those in practice. Some of them that are important is the ignore. So this is to silence a rule that floods your environment, so you can add an ignore in for that as well. So you ignore it for a certain amount of seconds, or however many long seconds you need, so that instead of 1 million events going into your Elasticsearch per second, you can tone it down to say only alert every 60 minutes. Just convert that to seconds and add that in. Overwrite is when you're creating a rule in the custom rules section of the Wazuh folder structure. You can create a rule with a conflicting rule ID, but then you have to add overwrite, which means that it will overrule the original rule that came with the system. And this is the only exception where you're allowed to use the same rule ID in the environment. And no alert will just mean no alert if it matches. That can sometimes be used for testing purposes. So this is what a completed catch-all rule looks like, a very basic one. So you can see that I've got my rule group, that's group name webinar, there I close it. You can see that I've stipulated what my range is for my alerts. And the first one is obviously the first number there. I specify the number as 3, which means that it's the lowest that I can set it without it being discarded. And I can say decoded as webinar multi, which is the name of the decoder that was being used to extract the data. This basically tells the system, just check for any data that's being decoded with that decoder. And then I just add a description that's pertinent to the data that I'm working with. Here is a more complex example. This is a rule set that I created for a port scan and detection tool. It's a very old Linux tool that is still in use in some cases. And this extracts syslogs from IP tables that's written to the syslogs, and it then maps it to a specific rule. So you can see I've got the catch-all at the top, which will just group the events coming in. It's level 3. Then you can see that I've lowered the next one to level 2. And the reason for that being is the tool sends basically 2 types of alerts. That's important. And I want to further classify those. So the first thing that I do is I split the data. So I create one that detects specifically what I want. And then you can check here at the bottom, if match SID is 22. Okay, I didn't copy that into the screenshot, apologies. Basically, it will then refer to the one that says 22, and it will map that message to it, but it will also apply if rule ID is 24. The level goes up to level 10 from the previous 3, then 2, then up to level 10. And the frequency is 15 times in 120 seconds. Ignore it for 720 seconds. And you can play around with those options to your needs, depending on what the flow rates are, etc. This is to prevent your system from getting flooded with the same alert over and over and over, because if you have an alert that's got exactly the same information, having 20 million of those alerts is not going to make a difference to your threat hunting. And that's another optimization that you can apply to your logs coming in to ensure that your disk doesn't fill up unnecessarily. So final considerations that you have to bear in mind is like, what is the goal of your rule? You shouldn't just create rules for the sake of creating rules. You need to identify what the purpose is going to be of it. If it's compliance, that's predetermined for you. If you're going to look at switches, but it's not compliance-based, what are you really interested in? If you're only interested in the source destination IP addresses and the source and destination ports, then you only extract those maybe with the host name or the source IP of the switch that you're collecting. So you limit the attributes that you're extracting in your decoders, and then you also create your rules and alerts based on that. Less is more, keep it simple. I cannot emphasize this enough. I have seen this numerous times where people try to get fancy too quickly. They haven't understood the logs that they're getting in. They do not understand what is being represented in those logs. They try to get too fancy, and at the end of the day, they spend weeks, sometimes months, creating decoders and rules, and they sit with something very fancy, but it provides them absolutely zero value. That is why it's important to look at it logically, extract what you need, and let the rest go. Don't reinvent the wheel. There are almost 3,000 alerts already inside Wazuh. Do not try and figure out something that somebody has already written 2-3 years back. Go through the rules. They're classified correctly. There are specific rule sets for specific types of logs. So you can find an equivalent rule that to the data that you want to do. You can interpret what they've created, and you can take that same design and build it into your rules. It is more efficient, it saves you time, and consistency is key. If you're doing it the same way consistently and you find a bug later, you know what you have to change in multiple other rules to fix that consistently throughout the environment. And the last one, be consistent. That is the biggest area of contention, because a lot of people always think they can do it better. They spend a lot of time and they end up losing a lot of time. So it doesn't mean that you can't do it better. It just means do not do this as the norm. Look at what's available. Discuss it. They've got an open forum. We've got an open forum on our website. Discuss it and see what options are available. Okay, questions. We're ready for the questions. Let's see if anybody has any questions they would like answered. Seeing as we've got a very small number of attendees tonight, I'll switch on allowed to talk. So feel free to just ask the questions if you like. You just have to unmute yourself. We do have a bit of spare time, so if you want to dive into a specific subsection of the rules, etc., I'll be more than willing to do that as well. Okay. I guess that means there's no questions tonight. Well, in that case, everybody, this video will be uploaded to our channel, as well as a link to the slideshows, as well as the rule set and the decoders for your review. Feel free to go through the videos, etc., and see if there's and the material provided, and see if there's any questions that come up. and feel free to add those to our forums, or if you feel you would rather speak to me directly, my email is available, and you can send those through to me. With that, I bid everyone a good evening.